Yes, I will continue with the example. Uh, yes, this example I was discussing in the last session. Yes, he has given one example. Consider the prefix codes giving some of the symbols and with the specific binary sequences. Okay, the question is using this code, decode the following sequences and draw the binary tree. This is a question here. A, B, C. Okay, A, B, C are the questions here. Okay, for all these three, we are going to decode this binary sequence. Okay, after that, we have to draw the respective binary tree. First, decoding the binary sequence and getting the some message. Okay, for that message, we have to draw the binary tree here. Okay, already we know that. Okay, how to decode the message, how to decode the binary sequence. Okay, yes or no? Any confusion in this one? How to decode the message? This is a given thing here. How to decode it? Sir, how to decode this one? Starting with first first letter binary sequence. That is one is there. You check each and every symbols whether that is held by the symbols or not. If yes, then put that symbol name. Otherwise, you can add one more letter to that one. Then again you check with all the symbols. If S, if any symbol is having that sequence, then you write the message, then you write the respective symbol. Otherwise, you can add one more next letter to that one, and do the same procedure till the end of the last letter, last sequence in the given sequence. Is there any doubt here? Okay, this is a encoded message EBAD. For this encoded message, we have to construct the binary tree. Okay, for doing that one, first we should construct the full binary tree. Okay, the height of the full binary tree will be the maximum number of elements in this sequence. Okay, you see here, four elements are there here, so that the height of the tree will be 4 here. 1, 2, 3, 4. 0, 1, 2, 3, 4. So that the height of the tree will be 4 here. Okay. After that, okay, put 0 to the left edge and put 1 to the right edge like this. Okay. Like this, we have 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. For the left nodes, put zeros. For the right nodes, put ones. Okay. After that, for each and every symbol which we have got after decoding, for that we have to label to the nodes. Okay, for all the symbols, okay, we have going to label to the each and every each nodes with the respective nodes. E is there. Okay, what is first E is here? No, you see what is E having the value 10. Okay, starting with root node. First one is there. Where should I move? To the left or to the right? To the right, I have to move because one is there. No, right edge is having one, so that I have moved through right edge. Okay, after that 0 is there. Where should I move? To the left edge. Yes, for this node I have labeled E here. E is one. Next B is here. Okay, here what B is having 0. Okay, starting from the root node, where should I move? Where should I move? To the left node. Yes, I move through the left node, left edge. Then for this node, I have labeled B here. Next, A is there. Yes, what is A? A is having triple ones. Okay, starting with root node. Where should I move? To the right because one is there. Where should I move? To the right itself. Where should I move? To the right only. For this node, I have to label A here because 1 1 1 three times A's are over. Then for this node I am going to label it as a here. Okay, then after that last D is here. Okay, what D is having the sequence 1101. Okay, now D is having the sequence 1101. Okay, double one means what here? Double ones, right node, yes, and after 0 is there. 0 after 1 is there. Yes, 1 means right hand. Here I should write the D here. Okay. After writing all these symbols, okay, after labeling all these symbols to the specific nodes, then we have to write the, okay, we have to rewrite the tree again. We have to rewrite the tree again like this. Okay, up to that node only we have to uh, shorten the tree here. Here you see, these are not required now here. For the understanding sake, we have taken all these things. Okay, if you are know very well, okay, how to draw, then directly you can draw this one. Okay, if you know very well the concept, directly you can draw this diagram. Okay, if you are having any confusion, better first to draw this one. Okay, then you do all this process, 0 then 0 1 0 1 0 1, for left edge 0 and for right edge 1, doing all these things. Okay, at last you filter the tree. Okay, then you write the like this. Here is B, C, B, E, D, A. C is not there here. Leave it. Okay, he has added here, but it is not there here. Okay, this is an binary tree for this message. This is an binary tree for this message. Similarly, for this will be an encoded message. Okay, again you need to draw binary tree for this encoded message. Similarly, what we did in this example, no, what we did in this A example, similarly we have to draw the binary tree for this encoded message. Similarly, C. Okay, this is a given sequence of binary numbers. For this sequence, this is a decoded message. Okay, I already told you that how to decode it here. After decoding, we have got this message. Okay, after getting this message, for this message we need to draw the binary tree. Okay, the structure of the binary tree will be, you have to draw only. He has not given here, but that is a homework for you. You have to go through this concept. Okay, keeping this as a base, and you have to draw the binary tree for B and C here. Okay. Yes. Yes. Next concept is weighted tree. Okay, just I will move with directly move with the example only. No need to go through all these things, otherwise you will be in confusion. So that what is required for your examination now, you see here weighted tree. Okay, the question how he is asking in examination is, okay, he is going to give one uh, prefix code. Okay, for this you need to draw a tree. Okay, after that he is going to ask you the question that find the weight of the tree. Find the weight of the tree. Okay, we'll see with an example itself. Directly I am going to with an example. Suppose uh, he has given example here. This is a tree. You imagine that this is a given tree here. Okay, this is a basic thing here. Okay, I will explain with a detailed example, okay, in the coming slides. Okay, in this we should understand how to calculate the weight of the tree. In this example, just to know about how to calculate the weight of the tree here. Okay, this is a tree here. Okay, for the nodes he has given some values, 8753, 8753. All these are the weights of the respective nodes here. Okay, 8753, all these are the weights of the respective nodes. Okay, the question how he is asking, find the weight of the tree here. Find the weight of the tree. Okay, we know that what is the height of this tree here? 0 1. You see the cursor, how I am moving over the screen. Just you see here, this is 0 level, 0 level, 1 level, level 2, level 3. So that the maximum height of the tree is 3. Okay, the maximum height of the tree is 3. So that with respect to the nodes, we are going to find the weight of the tree here. Okay, we are going to find the total weight of the tree. Okay, before that we should know what is the level of each and every nodes in the tree here. Okay, for this node, no, 1 2 3. Okay, you see here 8 7 5 3 are the nodes, are the leaves of the tree, no. You see here 3 5 7 8 are the weights for these nodes. All these nodes are the leaves in the tree because all are having the degree 1. You see here degree of this one is 1, degree of this one is 1, degree of this one is 1, degree of this one is also 1. Okay, all these four vertices or the four nodes are having degree 1, so that all are the uh, leaves of the tree here. Okay, with respect to leaves only we are going to do the calculation. Okay, here you see after that we are going to find the level, zero level. Okay, the 3, the weight 3 is at level 1. Yes, this is the level 1, no. And weight 5 is at level 2. Yes, it is at level 2. And 8 and 7 are at level 3 here. Yes, are a level 3 here. Okay, okay, after that we have to multiply each and every levels with respect to node weight. Okay, we are going to multiply level with respect to node weights and doing summation for further nodes. Okay, we are going to multiply level with respect to weight node and making the summation, okay, with all other nodes here in the similar way. How you see here, first 3 is there now. Okay, the level of the 3 is 1 here, so that I have written 1. Okay, 1 multiply with weight of that node is 3 here, it is over. Then plus is there, I have written plus here. The next weight will be 5 is there, the 5 is there at level 2. Okay, the 5 is there at level 2, so that I am going to multiply 2 into 5, 2 into 5. Yes, next 7 is there. Okay, the node, the weight 7 is there at level 3, so that 7 into 3, 7 into 3. Yes, over. Next one more plus, one more weight is there, that is 8. Okay, 8 is also at the level 3 itself. Okay, for 7 and 8 the level is 3 only, so that I am going to multiply 3 to 7 also and 3 to 8 also. Here you see 3 into 7 into 3 plus 8 into 3. Yes, this is the process. All are over, no. 3 5 7 8. Okay, for all these weights I have multiplied with respect to levels and do the summation in between them. Okay, the finally it will be the weight of the tree. Finally it will be the weight of the tree. Here you see the weight of, you do the calculation, finally we have got 58, so that the 58 will be the weight of this tree here, so that the 58 will be the weight of the this tree. Okay, similarly he has given some of the examples here. Here you see, okay, here what it is this, what is maximum level of this one, 0 1 2. Okay, the maximum height of this tree is 2. Okay, find the total weight of this tree, find the total weight of this tree. Okay, here in this tree 8 7 3 5, 8 7 3 5 are the weights in the tree here. Okay, all these weights are there at level 2, all these weights are there at level 2. Here you see level 0, you see the cursor how I am moving. This is level 0, this is level 1, this is level 2, so that all these weights are at the level 2 here, so that for all these weights I am going to multiply level 2 to all these weights here. You see 8 is there, 8 into 2 plus 7 is there, 7 into 2 plus 3 is there, 3 into 2 plus 5 is there, 5 into 2 plus 4 only, no, only 4 weights are there. For these 4 weights, 4 leaves, we have got this one. Do the calculation, finally we get the 46 as the answer here. 46, okay, is the answer here. Okay, next example you see here, for this tree, for this tree. Okay, find the weight of the tree here. Okay, find the weight of the tree. 11, 5, 2, 3. First, we are going to find the level for each and every weights. 0, 1, 2, 3. For one level, we have weight 11. So that I am going to multiply 11 with 1. Okay, one more weight is 5. The 5 weight is there at level 2. So that I am going to multiply weight 5 with 2. Yes, over. Weight 5 with 2 over. Next plus. Then again, I am having two more weights. Those are 2 and 3. Both 2 and 3 are at level 3. So that I am multiplying level 3 to the weights 2 and 3. So that 2 into 3 plus 3 into 2. Yes. Do the calculation. We have got something value that is 36. Something value that is 36. Okay. This will be the basic idea. This will helpful in further examples. Okay. The same concept I am going to use for solving the some of the bigger examples. This is a basic example only. Okay. He will not ask like these questions, but this will be helpful for solving next complex examples. Yes. I hope that this is clear for you all. Okay, if any confusion is there, put a message in the chat box. Put a message in the chat box. Any confusions? Any confusions? Just give me your attendance. Total, how many members are there for this session? In the previous session, it was 25, no, now it is 24. Yes, 20. Today date is 27, no?
28, sir.
28, huh? Yes.
Yes, sir.
And Adarsha? Adarsha. Adarsha is not there, huh? Yes. Aditya.
Yes, sir.
Anuradha.
Yes, sir.
Bharat.
Sir.
Bharat. Absent.
Yes, sir.
Are you there?
Yes, sir.
Okay. Bhavana. 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 Absent. Huh? Bhavana is absent. Huh? Dada Sahib. Dada Sahib is always absent. Dhanasri. Dhanasri.
Yes, sir.
Yes. Srushti.
Yes, sir.
Gayatri. Gayatri is not there. Huh? Gayatri. Absent. Janvi.
Present, sir.
Maithali. Maithali. Pratiksha. Pratiksha.
Yes, sir.
Niyaj. Niyaj.
Yes, sir.
Pooja.
Yes, sir.
Rashmi.
Yes, sir.
Rohan.
Yes, sir.
Rupesh. 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 Ruturaj. Ruturaj. Absent. Huh? Ruturaj. Okay. Samiksha.
Yes, sir.
Sanket.
Yes, sir.
Sapnali. Sapnali is there.
Yes, sir.
Okay.
Yes, sir.
Abhishek. Abhishek. Abhishek is not there. Huh? Abhishek. Sumit,
Yes, sir.
Vidya Kesarkar. Vidya Kesarkar, not there. Junaid Pasha, Vinod
Yes,
Hosur,
sir.
Vinod Jalli.
Yes, sir.
Okay.
Yes, sir.
And Vidya Kesarkar is not there, no? And Junaid Pasha. Junaid Pasha, are you there or not?
Present, sir.
Okay. Shubham.
Sir. Yes, sir.
Okay. 20. The class is 28 class. Solomon. Solomon. Absent. Yusuf.
Present, sir.
And Sharma. And Srivatsa.
Sir.
Venkatesh. Okay, all of you know how to find the weight of the tree. Okay, he will give, okay, the notes with specific weights. Okay, with that given thing, we are going to find the weight of the tree here. Okay, how to find means what here? First, we should know the level of each and every weights here. First, we should find the level of the respective weights. Okay, we know that already how to find the level 0 to the maximum height of the tree, 0, 1, 2, 3 till the end of the leaves in the tree here, the last leaves in the tree. We are going to multiply that weight to that respective level. Then doing summation in between the all the weights. Then finally we are going to do the calculation and we are getting the weight of that tree. Okay, just go through these basic ideas. Okay, this will be the basic thing for solving the next complex examples. Okay, I hope that everything is clear. If any doubt is there, put a message in the chat box. Okay, or you can directly contact me because no one is not asking the question. Okay. Yes. Next concept is, okay. Some things are there. Just what I am explaining now. Okay, you just move concentrate on that one. Okay. Next is optimal tree. Just wait for a while. I will enlarge. Okay, just wait. Optimal tree. Okay, given a set of weights. Okay, given a set of weights, if we consider this set of all the complete binary trees, okay, to whose leaves these weights are assigned, then tree in this set which carries the minimum weight is called an optimal tree. Okay, you see in this previous example, this is a tree, no? Okay, you see this example, this is a tree. Okay, I have assigned some of the weights to the all the leaves in the tree here. Okay, this is a tree. I have assigned some of the weights to all the leaves in the tree. Okay, after calculating the weight of the tree, okay, which specific weights are having the least weight, no, which specific weights contributing to the least weight of the tree, then that tree we are going to call it as a optimal tree. A tree which is having the least weight, a tree which is having the least weight, then that tree we are going to call it as a optimal tree. Just to observe here, uh, okay, given a set of weights, okay, he will use some of the weights. If you consider the set of weights to all the binary trees, okay, whose leaves, okay, we are going to assign the those weights to the all the leaves in the tree here. Okay, uh, okay, which carries the minimum weight is called the, after doing calculation of the weight of the tree, if you get a minimum weight, then that tree is called a optimal tree. Just to observe here, just to know the meaning here, a tree with minimum weight is called a optimal tree. Okay, what is optimal tree? A tree with minimum weight is called a optimal tree. Okay, we'll see with an example, then we'll have the clear idea on this one. Something is there here, don't worry about that one, I am going to skip here. What is essential for to solve the examples? I am going to directly move with the examples only, because without solving the examples will be in confusion, so that I am going to explain the concept along with the examples only. Okay, okay, you see here all these examples are very important. Okay, from these only you will get the questions in the external examinations. Okay, on this concept again and again I'm telling you that there will be one question in the external examination. Yes, you see here this question, okay, is asked many times in the examination. Okay, you see the question definition here. Construct an optimal prefix code. Okay, construct an optimal prefix code for the symbols, okay, a, o, q, u, y, z, some of the symbols that occur with frequencies. Frequencies meaning alternative, it is weight only. Alternative to weight, he has named frequencies. Frequencies meaning is weights only, occur with weights or frequencies. Okay, alternative name of the weight is frequencies here. Okay, either you can use frequencies or weights. Okay, don't confuse with this one. Okay, construct a optimal prefix code for the symbols. Okay, construct an optimal prefix code for the symbols. For all these symbols we are going to construct the prefix codes, optimal prefix codes. What is prefix code? No sequence in the list is not the prefix of any other sequence in the list, that is going to be called as a prefix code. No sequence in the list is not the beginning of any other sequence in the list is called the optimal prefix code. Okay, or prefix code. Okay, for these symbols a, o, q, u, y, z, for these symbols we are going to construct the, we are going to find the prefix code. Okay, he has given some of the input data here. What he has given input data, all these symbols are having some of the weights. All these symbols, okay, what he has given, a, o, q, u, y, z, okay, all these symbols, okay, are having some of the weights of frequencies 20, 28, 4, 17, 12, 7 respectively. Okay, he has given symbols with respect to weights here. 24 a for e, 24 a, 28 for o, and so on, so on, so on, z for 7 here. We have, first you should know what he has given and what he has asked. Okay, he has given the input thing, some of the symbols with specific weights. Frequencies means weights. Symbols with weights he has given. What he has asked? He has asked the prefix code of a, o, q, u, y, z. The prefix code of a, o, q, u, y, z. Okay, how we are going to do the calculation, you see here. Okay, the solution. Okay, just you see, arranging these symbols along with their weights or frequencies in non-decreasing order. Non-decreasing order means increasing order. Okay, arranging these symbols in the same way only you have to write in the examination. In the same way only you have to write in the examination. Don't confuse. Okay, yes, yes, arrange the symbols, these symbols with their weights in the increasing order. Okay, treating frequencies as weights, I already told you, no, frequencies as weights, and the corresponding symbols as an isolated vertices. Okay, these symbols we are going to treat the vertices or nodes in the tree. Okay, just you see, I am going to construct the binary tree. I am going to construct binary tree for these symbols. Okay, from the binary tree I am going to find the prefix code of these symbols. We'll see how. You see here, first we are going to arrange all the symbols in the increasing order of their weights. Okay, in the increasing order of their weights. Okay, here you see which symbol is having the least weight among 1, 2, 3, 6 symbols are there now. Which one is having least weight? Which one is having least weight? 4, no? 4 is least weight. The 4 is held by which symbol? Q, no? A24, you see here. These are the symbols. These are the weights respectively. Meaning 20 for A, 28 for O, 4 for Q, U for 17 for U, 12 for Y, and 7 for Z here. Okay. Arrange all these symbols in the increasing order of their weights. Okay. Which one will be the beginning here? You see 4 is there. 4 is held by the which symbol? Q is here. So that you keep. Okay. Dot. It is just like a node here. Dot. The labeling of that will be Q. The weight of that respective node is 4 here. Yes or no? Then after that, which will be there? 7 is there. The 7 weight is held by the symbol Z. Yes or no? So that I have written Z here, labeled Z. Below that I have written the respective weight of that symbol, 7. Okay. The next which will be there? 4, 7. Which will be the next weight? 12, no? Yes. The 12 is held by the symbol Y. So that I have put a dot here. Okay. Labeled as a Y. And I have written the respective weight of that Y here. Next. What will be the next symbol? 4, 7, 12. Which will be the next? 17. The 17 will be held by the U here. Okay. So that U with respect to that 17 will be the weight here. I have written 17 here. Okay. Next, which one will be there? After 17, 20. After 17 in the increasing order, 20 will be there. So that 20 will be the weight held by the symbol A. So that I have written dot A 20. Okay, the next one will be the 28. This will be the last. Okay, the 28 will be the last. That will be the held by the O symbol. So that dot represents the node here, the node of the tree here. Okay, I have labeled this node by O, and I have written below that one. Below, I have written the weight of that node here. This is the first step here. This is the first step. Okay. He has given some of the symbols with the respective weights. Okay, we have to write all the symbols in the increasing order of their weights. Here you see Q, Z, Y, U, A, O. Okay, I have arranged all these symbols in the increasing order. This is the first step. This is the first step. The next one is what here? Okay, compare. Okay, merge two nodes. Okay, merge two nodes together. Okay, which are having least weights. Okay, merge the two nodes. Okay, which are having least weights among all these weights. Okay, merge two nodes which are having least weights among all these weights. Here you see 4, 7, 12, 17, 20, and 28. Okay, among all these weights, which are having two least weights, 4 and 7. No, 4 and 7 are the two least weights among all these. So that I am going to club these two. Okay, I am going to rename. Okay, rename for the obtaining new node. Here you see Q and Z. Q and Z I am going to merge together. Okay, and the newly obtained vertex. Here you see after merging together, I am going to get a new vertex. For this new vertex, I am going to label it as a some label V1. I have labeled it V1 here. You can label by anything here. Just I am going to label by V1. Okay. Selecting two nodes which are having least weights among all these weights, okay, and obtaining a new node, and new node will be labeled by some symbol. I have labeled it by v1 here, okay. After that you put uh, new node with a new weight, okay. You combine 7 and 4, okay. 7 and 4, it will be 11. For new node weight will be 11 here. You see here in the bracket I have written 11 now, so that will be the weight of the new node v1 here. v1 is having the new weight 11. v1 is having the new weight 11, okay. This is the second step here, okay. For these two, okay, this will be the replacing thing here, okay. The remaining things we have written as it is. The remaining things we have written as it is. Y, U, A, O, okay. All these things I have written as it is, okay. This is the first step, this is second step, okay. And do the same process, until you get a single binary tree. This is a binary tree, no, this is a tree structure, no, until you get a single binary tree. How you will see, okay. Again you do the same procedure. Again you need to compare. You see here, Q and Z already have gone here. I have already merged together Q and Z, okay. After that we have got v1 will be the new node here. So that again you do the same procedure of comparing the all the weights among themselves wages, okay, and selecting two weights which are having least among themselves wages, okay. You see here v1 will be, you know, v1 y u a o. I am going to compare v1 u v1 already Q and Z all over, okay. I have got v1 comparing v1 y u a o, and which nodes are having least weights, which two nodes are having least weights, 11, 12, 17, 20, 28. So that v1 and y are having the least weights, so that v1 and y are having the least weights, so that v1 and y are having the least weights, okay. So I am going to club v1 and y. I am going to club v1 and y. Here you see v1 and y I am clubbing together and getting the new node here. I am going to label new node with v2, because already I have taken v1, no. So next I am going to take v2, okay. After that I am going to do the summation of these two weights. 12 plus 11, it will be 23, okay. The new node is having the weight 23, okay. Yes, it is there, no, 23, okay. And do the same process, arranging the all the things. Here you see 11, 12, 17, 20, 28, all these weights are in the increasing order. No need to shuffle here, okay. When you club these two together, we have got 23. 23 is more than 17 and 20. So that again I am going to rearrange the elements in the increasing order of their weights. U, A, v2 and o. u17, a20, v2 23, and after o as it is as written here, okay. After doing this one, again I am going to arrange the elements in the increasing order of their weights, okay. After increasing order I have got this one, okay. And do the same procedure, okay. And do the same procedure what we did. Yes, among u, a, v2 and o, which nodes are having least weights? U and A, 17 and 20. I am going to club these two together and getting the new node, okay. The new node will be the v3. Already v2 is over, no. I am going to name it as the v3. And what is the obtained node weight here? 20 plus 17 is 37. Now the newly obtained node is having the weight 37, okay. 37. v3 is having 37, v2 is having 23, o is having 28, okay. v2 v3 v2, in 5 minutes the session will be ending, okay. I am going to finish this one example. You see here, yes, okay. I am going to club with u and v, okay. I have got 57 here. again you need to arrange the increasing order. In the increasing order, V2, O and V3 will be there. V2, O and V3 will be there. Again I need to combine two nodes with least weights. In this V2 and O are there. I'm going to club these two together and getting the new weight. That is what here 23 plus 28 is what here 51, and naming it as a V4. Okay, in the increasing order, V3 will be the first, no, V3, and V4 will be the second. Okay, V3 and V4. Here only two things are there. I am going to merge together as it is. Okay, after merging, this will be the final thing here. After merging, this will be the final thing here. Okay, you see here, I have covered all these things. Okay, I told you no previously, until you get the single binary tree and do the same process. Okay, in this step we have got the single binary tree. Okay, after that we have to do what we did in this previous example, putting 0 over the left node, putting 1 over the right node, 0 1 0 1 0 1 0 1. Okay, and here you see U A, I have labeled, no, all the leaves are having the respective symbols here. Okay, and what question it is, write the prefix code of all these symbols. Write the prefix code of all these symbols. You see here, for you now, what is the prefix code of this one? 0 0, starting from the 0 to that symbol, starting from the root node to that symbol. 0 is here. Okay, from the root node it has gone through the 0 and 0. For you, 0 and 0. Here A is there. For A, 0 and 1. For A, the optimal prefix code is 0 and 1. Okay, for Q, 1 0 0 0. For Q, 1 0 0 0. Z is here. For Z, 1 0 0 1. For Z, 1 0 0 1. Okay, for Y, 1 0 1. For Y, is 1 0 1. For O, 1 1. For O 1 1. Yes, in this way we are going to do the calculation. Just to go through this example. Okay, if any doubt is there, means you can put a message or directly can call me. Okay, the session will going to end in 1 minute. Okay, in the tomorrow class I am going to discuss with the next example. With this your fifth model will be completing. Okay, tomorrow I am going to complete the fifth model, and will start with model 3, sorry, model 2. Yes, just wait.